When we talk of physical properties of common rock forming minerals, we talk of color, then form, then luster, then streak, then fracture, then cleavage, then hardness, then specific gravity, and then we have some special properties of minerals. And finally, we try to know the chemical composition of those minerals. In previous video, we have already discussed about the color of the minerals. There are some minerals which have very typical color of their own, but there are minerals which may be found in many different colors. So, color cannot be a sole property of identifying minerals. So, we have to see other physical properties also, that is form, luster, streak, hardness, fracture, cleavage, specific gravity, etc., etc. By applying all these properties, you can definitely identify most of the major minerals which are found in most of the rocks. Now, let us talk of form of a mineral. Form of a mineral is its outer shape. Form of a mineral is its outer shape, which is governed by its crystal structure. But only few minerals, they are able to get the perfect crystal structure. For example, this one is prismatic, this you can see prismatic mineral, and this you can see a very perfect crystal. Multiple crystals are growing at a same time, so they are hindering the growth of each one, and ultimately they damage each other, and we are very difficult to have perfect crystal shape. But if you can see this sample, a sample has to grow from some surface, so one part of this mineral will not develop, only the other part of this mineral develop. This is a quartz crystal with 1, 2, 3, 4, 5, 6, 7 and 8 crystal faces. This kind of quartz crystal somebody has found in hills and mountains, and he thought it to be ice. The word crystallos means ice. So, they have perhaps seen this kind of mineral and they thought it to be ice, but actually it was not ice, but this mineral quartz, which is having temperature of its formation 600 to 800 degrees centigrade. So, this is perfect pyramidal crystal of quartz, but as compared to this, we have another quartz crystals which are not having any crystal shape. So, a mineral may have perfect form and a mineral may not have perfect form. Depending upon its perfect shape, we name it depending upon how it looks like: pyramidal, prismatic, acicular, rhombohedral, flaky, etc., etc. But a mineral which is not having any perfect crystal shape, we call it to be massive mineral. We call it to be massive mineral. So, for example, you have a mineral here which is calcite. This is in perfect rhombohedral shape. This mineral you will find in perfect rhombohedral shape. All these are calcite crystals with perfect rhombohedral shape. This mineral crystallizes in trigonal system. This mineral crystallizes in trigonal system. Similarly, you can see the common salt. You can see the common salt NaCl crystallizing in cubic system, and you can see its form is also a cuboid, not perfect cube, but similar to cube. This mineral is losing its shape because of its reaction with moisture. When I got this sample some 10 years back, it was much bigger. Now it has become smaller and smaller because of moisture and removal of sodium chloride from this surface. Now you can see we can have some mineral which are fibrous in nature. You can see this is asbestos. See here, much finer one. This is asbestos. This is amphibole mineral. This is a variety of mineral amphibole asbestos. This is very thin, thread like, even thinner than thread. thinner than thread. The mining of asbestos has been banned world over. We used to make asbestos sheet, and we used to have asbestos sheet as a roofing material, but now it has been banned internationally. But in many places, at many places in India, this mining as well as making of asbestos sheet is still going on. But actually it has been banned because this fibrous asbestos goes into our lungs while we breathe and creates a problem of asbestosis. Asbestosis. Now you can see this mineral, this is muscovite, which has got the form just like a flake. It is foliaceous or flaky, just like a sheet. This is a sheet silicate also. So this is white variety, which is called as muscovite, and you can see the black variety, which is called as biotite. Both are in the form of sheets. Both are in the form of sheets. Now we have a mineral here. You can see this is called as beryl. This is a mineral beryl. See perfect hexagonal outline of this mineral. Perfect hexagonal crystal. But it can be found in a non-hexagonal form also, because this very mineral didn't got the chance of growing in perfect hexagonal crystal, because around it there must be some other minerals crystallizing. So neither they have got perfect crystal boundary, nor they have let other mineral to get the perfect crystal boundary. I will show you a sample from rock pegmatite, which I have said that this rock is called as museum of minerals, because the biggest size of minerals can be found in pegmatite also. You see, I have shown you the sample of this granite. This mineral has got quartz, feldspar, biotite and tourmaline. But if you ask me to take all these minerals out of this rock, it is very difficult. So most of the big minerals which you are seeing here, they are, if they are of igneous origin, then they have come from pegmatite. So in this also you can see the beryl with perfect hexagonal crystal outline. You have another beryl here, you have another beryl here. This white milky is quartz, and this dirty white is feldspar. The shining one is muscovite. So I am talking of form. So form is an important property which is governed by the crystal structure. Some minerals, they have radial or fibrous growth. Radial or fibrous growth, you can see here. So, and many minerals, they look to be massive. They don't have any regular shape. They are massive. So it all depends. Now I will show you a very important mineral, especially found in metamorphic rocks. If you can see this mineral, this is garnet. This is garnet. This is also called as mari. In Hindi, it is called as marik. This is the gemstone which is said to be protected by cobra. So you see, I have got this much big garnet, but there is no cobra with me. It is me who is protecting this mineral. So this mineral is crystallizing in cubic system, and this mineral has a habit of growing 12 faces. You see, one face, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11 and 12 faces. So this mineral is called as dodecahedron. Dodecahedron means it has got 12 faces. It has a habit of growing 12 faces, mostly if it is in metamorphic rocks. It can be found in igneous rock also, but there it will not be able to generate the perfect crystal boundary. I am showing you another sample of same mineral. Both may have different origin. They may be from many different places. Even I don't know from where they have come. This I have taken out from a rubble thrown outside Department of Geology. I have got it. Similarly, this mineral tourmaline, I have also got it from the thrown away rocks. And you can see another garnet with perfect 12 crystal faces. With perfect 12 crystal faces. So this is having a perfect. Now last sample I will show you. This is galena, lead sulfide. This one in my hand is massive one. This one is in my hand is massive one, and it's single crystal. If I can show you, perfect cuboid in shape. This is the mineral galena. This is a single unit of galena mineral, and in this we have thousands of unit of individual galena unit cells. So thank you for your patience and hearing. This was for form. In next video we will be trying to learn about luster and streak.